So questions 1 through 4 are all about writing equations. And in the directions, it says you're welcome to put your answer in any one of 3 formats. So the 3 formats that it was referring to would be point slope, which is my personal favorite, and you'll see why here shortly. There's also slope-intercept, which is 1 equals mx plus b, the one you probably have more practice with. And then the third one really isn't used too much in my opinion. It's kind of easy to write if you know like the intercepts. There's one called general form. And you're welcome to write your answers in that form. It's where you have this many x's, this many y's, and it would equal a constant. It doesn't really have the same benefit that the other 2 forms use, so most people don't use this one. Okay, so if you need to come up with an equation that goes through these 2 points, I'm going to focus on these 2, whether you're talking about slope-intercept or point slope. Either one of those, you need to know what slope is. So you have to know how to find the slope of 2 points. I guess you could graph it, plot them, and count rise over run. It'd be a little tedious, but that would work. Or the slope formula says find the difference of the y values. That's like the rise. And then in the same pattern, find the difference of the x values. And that's how you find slope. So, if you want to do, I'm going to do both forms here. I'll see how you can switch back and forth between them because I don't want to write all of these in all the forms. But if you wanted to do slope-intercept, y equals m, x, and all you need now is b. And b is supposed to be the y-intercept. But the y-intercept's not given to you, so you have to have some way to find the y-intercept. So, the way most people do this is they take either one of these points and temporarily plug it in for x and y. I'm using this point, plugging this in for x and this in for y. And that gives you an equation that you should be able to solve for b. See, it's not all that bad. But then you know your slope, you know your y-intercept. So y equals mx plus b. That would be acceptable. Now, since you have the calculator, you could have also graphed this and seen that it went through those 2 points. If you got something slightly different, that's how you could have applied the mistake. If that was your reference. So this would be slope-intercept. Or you could do point slope. Here's why I think you should prefer point slope. Point slope kind of has a formula to it that you have to memorize. You still have to determine the slope. That slope doesn't fit there. But point slope doesn't need a y-intercept. It just needs a point. Well, we've got 2 of those to pick from. I could have plugged this one in. And the values that you plug those in for are x1 and y1. So over here, I could have said minus x1, and over here, minus y1. That's fine too. It's saying the same thing as this, it's just in a different format. But if you go with this format, you don't have to do all those steps to compute the y-intercept. And there's nothing that says you have to use this point. You're welcome to use this point. So plug in the y value for y1, plug in the slope for m, plug in the x value for x1. That's okay too. The rest of today, though, I'll just always use the first point, but you can plug in any point as well. Okay, so you really can't do that on question 2 because this is supposed to be about a horizontal line. So the horizontal line, you need to know what a horizontal line looks like, left to right. you need to know what type of equation it has. It will always be y equals some number. And if you want to go through negative 1, 5, you picked that it was y equals the y value. Since it's y equals, you want y value. Every point on this line has the same y value. So no matter what x is, notice there's no x going in. No matter what x you pick, y equals 5. And your calculator can graph y equals 5, so another one that you can technically change with calculator. Okay, I'm going to skip down to number 4, because number 4 looks a lot like number 1. Regardless of which form you're going to use, you really want to know the slope. So it looks like your slope should have been 5 over 2. And so if you want to plug that into slope-intercept, plug in a point into slope-intercept, solve for b, plug that in with the slope, you can do that to get the answer. Or we could just use this one with point of slope, plug in the y value of the point here, the slope here, and the x value of the point there. And I guess that's okay, but subtracting 0 doesn't really do anything. So why bother writing it? And if you really want to add this 5 over, you could, and then it would be in mx plus b format. Okay, so number 3, we needed to find a line that goes through this point but is perpendicular to this line. So for this, you need to remember that parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So opposite as in opposite sign. This is positive, so opposite would be negative. Reciprocal meaning flip your fraction. 4 over 1 is 1 over 4. So compared to questions 1 and 4, I didn't even have to use the slope function. I just have to know that perpendicular lines have opposite reciprocal slopes. And then if I wanted to go to this point, again, think about what you have. You have a point and a slope. So why wouldn't you want to use point-slope form? Point-slope form is designed exactly for this. Plug in the slope here. Plug in the x value of your point here. Plug in the y value of your point there. There's point-slope. If you want to distribute the negative 1/4 to both of these and then add the 3 over, you could change it to slope-intercept if that's what you really want. Okay, so I do want to give you kind of a tip about your calculator here. You can kind of see this if you know what you're doing, but it's also a little misleading. So here's the original equation, 4x plus 2. And again, my calculator to graph this, I do have to at least add the 3 over because the calculator only graphs y equals for us. Okay, so this line is supposed to go through negative 1, 3. So that's easy enough to check. Let's go through negative 1, 3. But doesn't perpendicular mean they intersect at a right angle? Does that really look like right angle to you? Well, wait, this is negative 10 to 10, and this is negative 10 to 10, right? Right, so notice your calculator has more pixels horizontally than it has vertically. So naturally, it stretches that image a bit. It's not really drawn to scale very well. There is a way around that, though. If you hit the zoom button, you're used to seeing it in standard, but there's a choice right above it that says square, and so that's where your calculator compensates for that. And so if you're willing to change that zoom, then it better look exactly like the way. So you can still kind of check it by graphing it, but you may need to change the zoom so that you can have it squared up like it's supposed to be. Alright, so So you had your choice about how to write it. If you wanted to write it in a different format, that's fine, but you have a way to check with your calculator. Okay, so from the past couple years, the thing that people knew the least about was direct variation. This is not a hard concept at all. It's just that you either didn't learn it or you didn't struggle with it, so you didn't remember it. Does anyone have a guess about what direct variation means or characteristic about direct variation? Okay, so if it's direct variation, it will have a y-intercept of 0. It always goes through the origin. So if you're thinking about y equals mx plus b, if b is always 0, you really only care about this. And for direct variation, instead of calling it the slope, they usually call it the constant of variation. Just it's a fancy term. And instead of using m, they use k. It's the same thing. It really just means slope of the direct variation problem. So if you give yourself a visual, if you know this, if you know it goes through the origin, and then if I tell you this particular one also goes through 3, 2, you could kind of rise over its run, and you can see that the slope of this is 2/3. So in this case, that's what we call direct constant of variation. So there's the equation. Has a y-intercept of 0, and has that as a slope. And that's it. So another type of direct variation question. Say, for this direct variation, find the constant of variation. So this means figure out what k is, figure out what the slope is. So this might be where you need to add some notes to yourself. This means like the slope. Then find the value of y when x equals -2. So when x is -2, what is y? So there's really two parts to this question. Here's part 1, here's part 2. And what they're telling us is when x is -1/3, y is 6. So because this is direct variation, it's going to go through the origin, it's going to have a y-intercept of 0, and -1/3 So really, if you just put those 2 points down, it's a whole lot like question 1 and 4 now. You've got 2 points, so why would it need to work any differently? But it's also pretty easy to count by overrun. So we 6 and write 1/3. Dividing fractions is the same thing as multiplying by the reciprocal. That's the slope, which we call k, which is the constant of variation. Yes. And x is -1/3, y is 6, so slope is negative. It's coming down from all the way. You can whether it's going up and down and then to the right. Okay, so then, if we know this, we really know the equation. It's just that. So the second half of the question wants to know what is y if x is -2. So plug in -2 into that equation, and you get 36. So it's still a linear line, still talking about slope, You can still use run over run. You can still use slope formula if you wanted to. But to give yourself a starting point, you have to know this. When it says direct variation, it goes to the origin. And when it's talking about the constant variation, we usually use the letter K for that, and it's really just a different way to say so. Kind of like when we did vectors. Instead of saying that vectors were perpendicular, they were orthogonal. They just had a different name for them. Okay. Not hard, but definitely something you want to look at. Okay. Coming up with some of these graphs. So these are all good ones that your calculator is really only going to help you with one of them if you think about it. So I think the way most of you guys would have graph number 7 is to put this in Slope-Intercept Form. By solving for y. So subtract the 2x over, divide everything by -3. And I think the reason why most of you guys choose to do this is it's just a convenient way to graph. This is b, your y-intercept. There's 1 point. Your slope, you can count rise over run to get another point. You only need 2 points to define a line, so that's really enough. So feel free to count up 2, right 3 again, and again. Helps make it a little more accurate. Calculator doesn't let you type it in like this. If you solve it for y equals, it does let you type it in like that, and you can compare from there. On the front page, we said y equals a number is a horizontal line. So x equals a number must be a vertical line. And if it's x equals 4, it means any point on our line has to have an x value of 4. So that would be that. Very little work to be done, but you have to remember that about vertical lines. Okay, piecewise function is where you have a function in 3 different pieces. So in the past, this has been one that people spend the most time looking back at. So you definitely want to give me your full attention here. So sometimes our equation is y equals -4. Go ahead and graph that. Sometimes our line is y equals 3x minus 2. So graph that. And sometimes our line is y equals 2. So graph that. Now, this can't be your function. This is not a function. This doesn't pass the vertical line test. There's too much stuff going on here. So I didn't even look at the restrictions there. I just said it. Sometimes it's this, sometimes it's this middle one, and sometimes it's the bottom one. I just went ahead and graphed the 3 lines. You don't need to think about when is it each of these. So it's really only y equals -4 if x is equal to -2 or less than -2. So for that equation, I need to keep this piece of it and not the other. X is equal to -2 here and less than -2 there. Okay. So this one. Bottom piece, y equals 2, but only when x is greater than 1. So here's where x is 1. Here's where x is greater than 1. Now this one doesn't say equal to, so the way we use for that is an open circle. No open circle is not there. Not any of the rest of that equation. And then finally, this middle equation is when x is greater than -2 Here's where it equals -2. It doesn't say equal -2, so that has to be an open circle. Where x is greater than -2, but less than or equal to 1. So it ends up hitting open circle here. Build in circle there. But none of the rest of it. This other stuff is x values outside of this restriction. So notice what I have left is an line function. What I have left does pass the vertical line test. It only hits -2 in one spot, here and not here. It only hits 1 in one spot, here and not there. And everything else only gets hit one time. So if you can graph these 3 lines, you just keep this part of this line, this part of that line, and that part of that line. And that's all it is to make these functions. Okay, so the next one, question number 10, was the one that you could graph in your calculator if you know how to do absolute value. But really that's a lot of unnecessary work because you really should know what the absolute value of x looks like. That's a parent function. And this -1 on x is going to shift it right 1. So I guess use a calculator to help you check if you want it. But that's all there is to that question. Or for that matter, you could have made a table, plugged in some random x values until you figured out your practice. Okay, change the slope-intercept form. So this is what I did for question 7. I have to graph it. Slope-intercept form. This one, solve it for y. So subtract 2 x's from both sides. You should have a step that looks like this. Divide both sides by -5. And then you should be done. Okay, so maybe one of the most important things is if you understand absolute value graphs, what they look like, and you know what a piecewise function looks like, where it's split up into pieces, rewriting this into a piecewise function is something that has to be done quite a bit in calculus. And I know that you've done that before. So let's think about this graph. This graph when you want to graph absolute value, as I said, it's in the calculator, but you may not remember. It's in somewhere in the menus, and I never remember where. So, since I'm worried I won't remember it even if I look it up, just hit second 0 to pull up the catalog. The catalog has everything, and so ABS is for absolute value, and so that's very convenient. Anyway, so this is what the graph looks like. Still B, it's the absolute value graph. A little bit thinner. Shift it up to 0. Okay, so what you need to see when we're trying to write a piecewise function is that you've got 2 different things going on here. You've got a vertical line here that we just want this part of, and we've got a vertical line here that we just want this part of. That way we end up with this as a graph. Okay, so your 2 equations, one of them will be exactly the same as this absolute value stuff without the absolute value. So would that be this line, the green one, or would that be this one, the orange one? How do you know that? Positive slope and a negative intercept, either one of those, right? So where we want it where x values are bigger than whatever's happening here. We're going to have to figure out where they're changing hands there so that we can plug it in. But the other equation is the exact opposite. So if you multiply this by -1, that represents this line. So it's not hard to find the pieces. This comes from this without the absolute value, and this is this times by -1. And that is the green line, and I would put the x values less than that. So I want the left half of this.
Would both be less than there and have to be like less than or equal to, since they're both input?
One of them needs to say equal to, and it doesn't matter which one. Now, if you say both, then it's like you're including that point twice, so you kind of get into really past the third contrast, because that would be at one instance hitting the same spot but two different times. So I would say put the equal sign with one of them, but it doesn't matter which one. So where it's changing hands here is where we want to say this is changing over here. So we have to figure out this point of intersection. So if you use your calculator and you can zoom in. Based on the equation, hopefully you have a good guess of what that is. I guess you can type it in. Where do you think that might be changing? Okay. The third is correct. So you could do it that way. Or just do algebraically. Where does this, it's changing hands on that x-intercept where y is 0? So set it equal to 0. And see that it happens at 1/3. So that would be a different one. I mean, I guess you at least need to see that it's happening when y is 0, but and you're doing a little bit less calculator, a little bit more in your paper. So either way, you need to figure out where it's changing hands. But this would be a good place where you might write yourself a note. Where this came from was from this, about the absolute value. Where this came from was the opposite of that. These came from where it's switching from one equation to the next. And you've got a few different ways to find where that is. Through the calculator and or through some algebra. Okay, so if you scan through your page real quick and see what kind of specific questions you would like to ask that you want to add to your page. What else do you think you need to know to study with? Sure. So let's look at this question one. I would probably still do it this way or this way. But if you really wanted to put it in general form, and like you still are going to take the ACT again, I wouldn't be surprised if you had a question where it wasn't general form. So this general form wants the x values first. I would probably add these over, and I would say there's 3 x's. And then it wants the number of y's. So add this over 3 x's, 1 y, and then that would be equal to 3. That's the general form. This number of x's, number of y's, and then a constant. And I don't think it'll ever happen to you, but sometimes in college you might have a professor that's kind of tricky about it, and the real unfortunate thing about these are a value. Some people say that a just needs to be positive. Some people say that it needs to be a positive 1. So like in that case, you'd have to divide everything by 3, and there's really no rhyme or reason. There's no benefit to do one or the other, because some people are picky about it. So for that reason, most people also just don't care, because it's not really that useful. And slope is great, because it's easy to work with. We often have a slope and a point. Slope-intercept also got some benefits, because it's easy to graph, but as long as you know how to rearrange them, you can put it in general form. We won't specifically make you put it in general form. You're welcome to do that if you want to, and I won't have it wrong if it's correct, but you won't have a question where it says you have to do general form. Okay, so that's the question. Anything else you guys notice you need to add to your notes here? Okay, so it is